Rethink Vertical podcast. On today's episode, I sit down with Manu Lubrano, CEO and co-founder of INVOLI. Manu has 12 years in the drone industry and has led the ASTM committee focused on a standard specification for surveillance supplementary data service providers. In the past, Manu was president of the Swiss Drone Industry Association and board member of the Global UTM Association. Before co-founding INVOLI, Manu was head of industrialization for the Swiss drone manufacturer Sensefly. He is also the co-founder of Drone for Earth, an NGO using drones for humanitarian aid, which enabled him to gain valuable experience as a drone operator in challenging environments. In our conversation today, we focused on a few critical concepts necessary for UAS scalability that INVOLI is concentrating on. Those are accurate aircraft detection, using certified third-party data service providers to keep operating costs down, and how to fuse all of that data into a trusted and usable product. Hope you enjoy the episode. All right, welcome Manu to our Rethink Vertical podcast. It's great to have you with us, and I look forward to our conversation.
Hey Craig, thanks a lot for having me here. Looking forward to it.
Yeah. Sorry we couldn't do it when we were together in Switzerland and even in San Diego, but we're here now, and we're gonna do it remotely. So I'm glad we could make this conversation happen. Really interested for folks to hear about what you guys are doing and talk through some of these really interesting questions. But before we kind of get into the questions, everybody has sort of an interesting path to this industry we're talking about, this emerging aerospace UAS industry. And I'm not sure I know the whole story of how you ended up here, so I'd be curious to hear that, and then also a little bit about INVOLI and what the company's working on.
Yeah, absolutely. That's an interesting question. So I actually entered in the drone industry in 2012. So I've been there for 12 years now. I was working for the drone manufacturer Sensefly at the time. So I was responsible for production, for externalizing the production of different drones and so on and so forth. But during my time there, drones have a really bad reputation. It was the time of Afghanistan and so on, And we have some colleagues that were insulted by their grandmother, like, you are working in war with drones. This is really bad. And so we decided to create an association to use drones for humanitarian means. And in that case, I transformed myself into a drone operator. I was actually a real drone operator. And we did several missions around the world. It was very interesting, really showcasing any possible application of drones. And then all of a sudden, there was this terrible earthquake in Nepal. We organized several drone operators to go there to help authorities to, save people, cartographing how the city changes after the earthquake. And so we get there, and actually the aviation authority said, no, you are not supposed to fly. There are too many helicopters in the area, so you will be actually be an hazard against the helicopters that are doing their work. And then at that point, I realized, yeah, but if I could see the position of the helicopter into the controller of my drone, I could avoid it very easily. And at that point, the idea for INVOLI came out. And from there, it was all a matter of what's the technology that allow me easily to detect the position of airplanes or helicopters flying at low altitude. And then how can I inject this into the software that I use to control my drone? So we created INVOLI in 2017, and this was really the genesis of the idea that helped us creating all the concept that we have today.
Right. So this idea of, okay, how do we capture all the appropriate aircraft track data sources, put them in one place, so operators can actually see and operate safely, and then also give regulators that warm fuzzy that they're going to need to approve scalable operations. Right.
Look, from one side, actually, if you are a drone operator and sometimes you fly close to an helicopter, it's actually scary. Yeah? So it happened to me a few times, and because of parallax, you are not really capable of seeing where is your drone towards the helicopter that is close to you. It's a matter of perspective. And so actually having the icon on your screen, it's really reassuring. It allows you to leave this matter in an easier way, let's say.
Right. That's a really good point. And I'm not sure anybody's brought that up before for folks that have never flown a drone, especially around aircraft. It is, just because we say line of sight doesn't mean it's safe, right? Because if you're operating, even if you can see both aircraft, you don't know what the other pilot is doing, what they're planning to do. You don't really know how close or how far apart they are unless you have some other data source feeding that data to you to tell you that your eyes aren't playing tricks on you, right? That's and I think yeah, a lot of folks they assume, and I think it's true even for traditional aircraft, right? I'm a pilot myself, so flying on a Cessna 172 and looking for other aircraft, like seeing them visually, your mind plays tricks on you if they're above you, below you. Are you converging? Are you diverging? Right? It's not black and white like a lot of people think. So, um,
Exactly.
yeah. So let's talk a little bit about aircraft drag data. You talked about you saw the need for it. Why, for the folks listening, why is it so critical to have that track data, especially when we're talking about scaling commercial U.S. operations?
Yeah, it's actually extremely critical because the business want to fly BVLOS. All the assumption behind the rentability of drone operation is related to the fact that this can scale extremely fast, that you can use hundreds and hundreds of drones in the same area, maybe with just one pilot supervising them. And this is possible exclusively when your system is allowed to fly BVLOS. And to do so, you need a system that gives you um, airspace awareness. You need to see where there are the airplanes around you so that the system itself can take care of them and avoid them automatically. That's the final vision of where we are going. Then today, obviously, we are not yet there. There are many things that need to be put in place. But at the end of the day, is we need to do this operation as cheap as possible. And to do
Mm.
so, we need to have this detection system that is distributed and then created for all the drone operators that's around that can actually benefit from it at a price that makes sense for their business.
Yeah. Can you talk a little bit about, from a company standpoint, what are these data sources that your team is using? Is it being displayed? How do you analyze the data? How do you make it useful to operators? Talk through that a little bit.
Yeah, absolutely. So we rely exclusively on the detection of cooperative air traffic for the moment. So it's really a matter of detecting transponder signals. When we're talking about the US, we talk about ADSB, UAT, MODES, MODAC. MODES, MODAC are the oldest one, of course, but the other one also provide the GPS position of the airplanes directly into the messages. This is the principal source of information that we are using. Then what we add on top of that is multilateration, which is a process that allows us to calculate the position of the airplane. Let's say it's a sort of triangulation to make it
Hmm.
simple. But basically, when we receive a signal, we are always capable of calculating if the airplane is actually really there. And in reality, the airplanes can send any signal without even a payload that makes sense. We're always capable of calculating where the airplane is. And this is something that FAA and other aviation authorities likes a lot because in case of spoofing or in case of scenarios where airplanes are manipulated wrongly to change
Hmm.
drone operation and so on, we can really say, no, no, there is an airplane there. It's for sure. All the other things are fake and so on.
Right, right. Well, and it's critical too. Think about, folks don't realize you can have, you could have 1 to 5 different data sources from where the aircraft is
Mhm.
feeding simultaneously. And
Yeah,
if they're not being merged together, right, you're going to get duplicate tracks. You're going to think, this aircraft is here, but it's actually a half mile over here because you're getting a radar feed and you're getting ADSB data. And so that's super critical for the FAA, is fusing that data together and having a high level of confidence that the aircraft is where it says it is, and you're not getting, and like you said, it's harder to spoof the data that way.
that is true.
So
That is true.
that's, yeah. I'm sorry, go ahead.
Yeah, imagine that even in our system, sometimes it happened that the same airplane is detected 3 times. Like
Right.
an ADSB airplane can be interrogated in MODES and MODAC from radars. And so we will see 3 times the icon. And then today we have a fusion stream where all this information are brought together so that you see only one icon, or if you're using our API, you are just getting one position per aircraft. But it's very nice because at the end of the day, it's also a sort of a redundancy internal to the system so that you can have multiple way of detecting the same plane.
Right. Right. Just a minute ago, you hinted at, U.S. versus Europe or UK or other ANSP regulatory agencies throughout the world.
Mhm.
Um, and we were kind of joking about this before we started the podcast. This term aircraft conspicuity, and how I had heard it for the first time a couple of months ago at Airspace World, and in 26 years I'd never heard it before in aerospace. Um, so, how are regulators in different parts of the world thinking about aircraft conspicuity differently? And does it seem to be that folks are starting to kind of line up in the same position, or are we still pretty far off on requiring aircraft to sort of be seen in the airspace? What are you seeing on that front?
Um, I would say that today the industry is a little bit fractioned, let's say a lot. Even there are even
Right.
difference between the United States and Canada on how manage this. For example, on the matter of should a drone be capable of sending its own position of ADSB or
Mm,
not, for example. Then we have the matter of UAT existing only in the United States and being somehow tested in the UK, but not really. Let's see how this goes. Then we have a
mm,
FLARM in Europe that we don't have in the United States, which is or limited anyway, which is an open frequency that is mostly used by glider and general aviation. So there are
okay.
really a lot of different ways of be inconspicuous if you are an aircraft. In
Hmm.
the U-space conundrum in Europe as well, um, they create basically if you want to fly an airplane into a U space, you are obliged to be conspicuous.
Right.
You cannot fly in a U space if you're not conspicuous. There are three possible ways. One is ADSB out, one is mobile, and one is the future ADSL, which kind of exists on paper but not yet for real. So it's also a very dynamic scene. Everything is moving quite fast, and we are seeing how industry and people are going to adopt these new technologies.
Yeah, the use space concept, I find it interesting too, because if you look at some of the recent exemptions within the Mode C veil in the U.S., it's sort of paralleling that same concept, right? It's like, okay, the FAA has said, and the operators have recognized that, okay, the Mode C veil aircraft are required to have ADS-B, and so that's sort of like a use space. Aircraft, if they're operating in that airspace, they have to be conspicuous in some way.
Yeah.
We know that's not 100%, but they're supposed to be by rule. Um, are you? Is it the same as use space, or is it different, or is use space much more controlled than sort of like a mode CVL? Like, how do you see that?
Let me think. So my understanding is that what we have today in the United States in Mod Civil is something that today it's a easy usable. So it's ADSB, it's Mod C, everybody's
Right.
conspicuous already today. So let's do our operation, let's go. While on the other side, in Europe, what we have is today we don't have U-Space service provider which are certified yet. And then
Mm.
all this part of e-conspicuity, sorry, it's a really difficult
It is a tongue
word
twister,
actually.
right?
It's something that need to be implemented. So somehow
Mm.
we are not ready yet at 100% in Europe to go and say, okay, here is the first use space of Europe, let's go. And so this is why slowly the interest is moving for a company which have an international reach towards United States because we have the
Mm.
impression that we can go to market faster there.
Right. That's interesting. So even though the concept came first in Europe, the
Mhm.
operations are moving back to the U.S. because the rule has existed for a long time.
Correct.
So when are we expected to see the first use space operations set up, and where are they going to happen? Do we know?
Yes, there are some areas which are very active in Europe where there are a lot of drone operation like Port of Antwerp or Port of Rotterdam, if I remember correctly. What is
Mm.
interesting is that in these areas, drones are flying and there is a business reason for them to fly. When there are use space which are created or demanded in area where there is not really a business demand, things goes really slowly. People don't understand
Right.
why there is a need for a use space there. But in those particular areas where drones are going to fly for business, it actually go fast. Actually, use
Yeah.
space is not yet needed. Like you can fly without use space. There are some arrangement that allow to fly. So that's interesting. Then, if you ask me when the first official use space in Europe will be out there, I have actually no idea. It's really
Okay. Right.
complex.
Right.
I
Right.
can tell you that there is a fight, let's say, between a competition between different countries in Europe to who has the first use case out there. But on the other side, there is also a big discussion on should be the system centralized or not, with the ANSPs looking forward to centralize all the information that is provided to ANSPs. So there are some slowing down in this kind of matters.
Yeah, no, it totally makes sense. I understand the level of competition
Mm-hmm.
between countries on this concept.
Yeah.
Um, so when we think about, let's talk about infrastructure a little bit, right? So the way that Involi operates is, you set up receivers, you set up equipment to receive these signals, you provide that data to customers through your platform. But there's physical infrastructure needs. It's not all digital, right? There's a digital piece. There's a physical infrastructure piece. It's not free, right? It has to be built. Somebody has to pay for it.
Yes.
Can you talk a little bit about how are you envisioning funding this type of infrastructure? How are you guys rolling it out? What have you learned over the past few years about how you do that? Um, I have a particular interest in this, so kind of curious, where you were and where you are today, and how you're thinking about that funding that infrastructure.
Yeah, that's a very good question, and actually one of the most difficult
Mm,
one that we are facing with our business. When we start Involi, we didn't know that infrastructure business was one of the most complex, even because venture capitalists and so on tend to don't like to invest in
yeah.
infrastructure. So the too long did I read reply to this is we need to install our system exclusively when there is a business demand for it. The example of Germany is something that is very interesting for us because we have
Hmm.
full coverage of the country, which has been paid by customers which use it for a business reason. So in Germany, there is a regulation for which wind turbine have to switch off the red obstacle light on top of them because it's considered pollution, but they have to switch it on when an airplane is incoming.
Right,
So
right.
a way to detect air traffic is needed. Hence, we install our system for this particular reason. Somebody paid for the system, and now it's available there for everybody. So if you don't have this initial business trigger, it doesn't make sense to install a network of receiver. So that's again exactly as like I was saying before for use space. The
Hmm.
business is actually who is triggering all the investment in the infrastructure, in the software, in the scalability, and so on and so forth. So once you have this, you can you can do all the rest. Then, of course, government can always help in this kind of infrastructure. Is if part of these expenses are paid by government by subsidies and so on, it makes sense. It is absolutely needed. But we have an expression in Italy. We say it. Let's don't build cathedral in the middle of the desert. We need to do
Right,
the
right,
infrastructure only in area when at the end of the day somebody is going to use them, and that's it.
right. Um, for your Germany use case with the wind turbines, are there rules that require everyone to be conspicuous? Like, how does that work, or do you have to integrate radar somehow into that? How do you do that in Germany?
In Germany, for the moment, we are reselling this data in the context of SORA, which is a methodology
Okay,
that allow to demonstrate to aviation authority that you are lowering the risk of airspace collision and so on. So
right.
today, this is the status quo. But of course, if tomorrow there is going to happen that there are use spaces in Germany, we can provide our system as traffic information service. This is how
Right.
it's called in Europe, while in the US we call it SDSP, supplemental data service provider. But at
Hmm.
the end of the day, it's the same thing. We provide surveillance data for drone operations.
Right.
Mhm.
Yeah, I'd like to dig into the SDSP concept too. I know that you were pretty heavily involved on the ASTM side, on the surveillance SDSP. We're talking about providing data as a third party data service provider.
Yeah.
Can you talk a little bit about like what is a surveillance SDSP, and what's the point of the FAA building out a process for somebody to be certified to do that, or certifying an area for that data provider? What's the point?
Yeah, that's a very good question. Supplemental data service provision, that's the meaning of SDSP. And the key actually is in the word supplemental, which means that with our system, we are capable of supplementing the infrastructure that is already available today. So there is this false idea that when there is a radar in an area, then there is full coverage. And so with a radar from an airport, you are done. There is no problem. You don't need any other detection system. But in reality, we're realizing that aviation radars are very good in tell you what is happening close to the ground in the airport itself, but very fast the coverage goes up, and actually you don't see what is happening at low altitude, which is actually what is important for drones. So we come with our system, we install our receiver, and with our system we supplement the data from the original aviation radar. In that sense, we are able really to provide a complete air traffic detection built on our system and what is available already today. The thing that is interesting is that the use case of drone is different from the use case of aviation. Drones are going to fly in areas where today helicopters or planes have no need to be detected. And so with our system, we bring this detection on top of that to really enlarge the coverage to a whole area.
Right. Yeah. So you mentioned kind of the way radars operate, and that was really the whole the whole point of developing ADS-B in the U.S. Right. Specifically, was
Mhm.
there are so many areas where radar coverage is just not it doesn't go low enough, right? And so
Mhm.
we need some other sort of technologies to provide us that extra layer of radar or layer of surveillance. We don't get rid of radar; we keep it, right? Because we still need it, but we're adding that extra layer. And
Mhm.
I imagine that with drone operations, what you guys are doing is the same thing. You're adding extra layers of surveillance so
Yes.
that everything works together, provide the cleanest and safest surveillance picture you can, because now you have a whole other layer where aircraft are operating where other aircraft may operate sometimes, and they need to know where each other are, right? When they're in those spaces that sort of merge together.
That's absolutely correct. That's exactly what we want to do.
Yeah. Um, so you guys have been, and I think I know this is public as of San Diego. I think starting to work with some radar providers, um, particularly because of the use cases in the U.S. Right, where um, other than the Mode C Veil at Class B airports, it's a very small Mode C Veil at Class C airports, which is not as useful for drone operators.
Mhm.
Um, Using radar and integrating that into your system to be able to see non-participant, excuse me, non-participant aircraft. Want to talk a little bit about your partnership with Matrix Space and how you see that sort of moving forward?
Yes, absolutely. So we were really excited to announce this during Exponential in San Diego. But long story short, Matrix Space is a manufacturer of primary radar of small size, which are very, very small and very efficient for what they do. And we found that both the company and both the technology are very complementary to what we do. Like we are very good and specialized in the detection of cooperative air traffic. Likewise, they are very good in detecting non-cooperative air traffic. They have an interesting solution because towards other technology that is available today with a radar, you can basically detect everything, which is very interesting. Works also at night, works in bad weather. So for us, it was kind of the obvious partnership to put in place because together we have really the solution that allow you to see all possible aircraft around a certain area of interest. Then the objective would be to see how this develop on the business side in the US. In my opinion, there are a lot of different verticals that we can address together, not only the drones, but also anything related to safety, to surveillance, not in the aviation surveillance, but you understand what I mean. So we are really excited about this partnership. Yes,
Yeah, just general surveillance, right,
general
of every
surveillance, correct.
of everything. Um, so I know you guys got a lot of really interesting projects going on. You got some of them on your website, which folks can check out.
Mhm.
Are there a couple of different projects that you're excited about that folks should know about that are of particular interest?
Yeah, so besides the coverage, the whole coverage of Germany, which is incredible because it's I think 400 receiver or something like that are really installed, and so we really have this coverage up to the ground of the whole
Right.
country. So we have data which were impossible to have a few years ago. The second project that I want to mention, which is it's just started 2 weeks ago. Is a deployment that we did in Romania for an airport. So we sold our data and our system for allowing this airport to do flight information service. So, which is our first step more in the aviation, in the traditional aviation world. And we really look forward to that, and we look forward to have more airports which will subscribe to the same solution. So in this case, we contacted the local towerco. We install ourselves the receivers. We had another partner, the company Ansart, which installed the screen, the computer in the control tower to allow them to see our data. And then finally, we create this full solution that allowed them to have this nice traffic awareness, and they didn't have to bother with the installation of infrastructure. This was all done on our side, and the system was ready in a couple of months of time, and which is an incredible time for aviation.
Right. Normally, it's a five-year process to get something like that installed.
Yeah,
into a
exactly.
tower
So
environment.
what is really funny is that it took us 3 months to do the commercial relationship with the towerco. But if tomorrow there is another airport in Romania which want to have the same service, the contract with the towerco is already done. So it's really a matter of a few weeks to send the receiver, have them installed, and that's it. So it's I think we're really slowly bringing all this surveillance business into the future, like leveraging the IoT technology that we have today, and this is really exciting for us.
It is very exciting, and I think you're hitting on something that, from a traditional air traffic perspective, we've been okay not knowing where everything is, maybe incorrectly, right? We know that in the tower environment at the airport, right around the airport, it's extremely important for critical safety operations. But just outside the airport environment at low altitude, where you have helicopters operating, it was sort of no man's land. And so I think as you talk about those companies starting to see that, we can make our operations safer. Flying helicopters at low altitude, life flight, lifeguard helicopters, it's dangerous business. And so, having that next level of data that you could use that is reasonably priced, right, is one of the key pieces. So it'd be interesting to see how that piece of your business expands and scales.
I think the point of reasonably priced is the most important one. Let's say with what we are doing, I feel like when in the 80s, the first mobile phones were out there, maybe there is one mobile phone. You cannot install a whole network of infrastructure just for one dude having this mobile phone.
Right.
And especially you cannot imagine that this poor guy is going to pay for the whole infrastructure, So the
Right.
point is, we really wish to have a price point for our system that is open to everybody, to allow the industry to grow. The problem is that we need a lot of customers in order to have this price going down for everybody. And this is really one of our goals. And this is also why we keep exploring verticals that are going to use the same data, so that at the end of the day, the system will be cheaper for everybody without compromising on quality of the data.
Right. That's really key. All right, Manu. Well, it's been great. Really enjoyed the conversation, and look forward to seeing you in person whenever that might be soon.
Yes, Craig. Thank you a lot. I enjoyed this conversation as well, and looking forward to see you as well at the next conference on Econ Speaker.
Right. Yeah, right. All right. Thank you.
If you'd like to be a part of the UAS Cluster Initiative community and get access to more of our content, check us out at www.uascluster.com.